At the very tip of Africa lies iThemba Laboratory for accelerator-based science, the largest accelerator facility in the Southern Hemisphere and the only cyclotron facility on the African continent. iThemba Labs offers unique research capabilities to local and international researchers. The Cape Town facility also produces radiopharmaceuticals for the diagnosis and treatment of cancer. iThemba Labs is where science comes to life, where real people are using science in various ways to impact the lives of every South African. Visit their Facebook page, iThemba Labs Cape, or email director@tlabs.ac.za. Okay, we are joined in the studio here by Dr. Sizwe Buwa. Doctor, how are you doing?
Very well, thanks. And yourself?
Fantastic. It's always a great honor and privilege for me to talk to the scientists of iThemba Labs, because I can't believe what you guys are actually busy with right here in the Western Cape. You guys work with some of the biggest companies in the world when it comes to technology and human advancement. So iThemba Labs is a great representative of South Africa, advancing knowledge, transforming lives, inspiring a nation. And experimental research at iThemba Labs need three things, namely a probe, what we use to study accelerated particles, a target, what we want to study, and a detector, what we use to see. And this we have learned with our conversations with iThemba Labs up to now. And this is similar to when you study a sample specimen under a microscope, light sample, lenses, etc. So let's meet Sizwe, the face behind target engineering at iThemba Labs. So, Sizwe, I have heard of engineering, but what exactly is target engineering?
Good afternoon, everybody. Good afternoon to you as well. And good afternoon to your listeners at home. And thank you for having me. What is target engineering? Okay, firstly, this is a discipline that cuts across three major disciplines. That is your chemistry, physics, and technical as well as manual skills. As an added advantage to this, you also it is very useful to have some knowledge of crystallography, metallurgy, and vacuum technology, at least on a basic level.
Wow. Okay, so you make the target with which the beam of particles is interacting. If the particles are small, does this mean that the target is thin? How do you make these things thin? And how do you measure the thick or thinness of these things?
Okay, thank you very much for such a question. The best way to answer these questions is to first have a nuclear target a requirement scenario. Targets that are used in nuclear research have various shapes and dimensions. Thickness, physical, by that we mean are they solid, liquid, or gaseous, and chemical, are they elements of compound nature. And all these are basically the forms that you are required. As you mentioned in your advert earlier on, an accelerator is able to deliver high energy particles onto these nuclear targets, and obviously this triggers a reaction. Thereafter, this reaction is carefully monitored in terms of the energy given off, and its data is collected and for interpretation.
Okay. Is there anything you want to add on to that? Because I always feel like there's so much more you guys need to say, but it's so much information. What comes after that?
Yes, just to go back to your question, that's got to do with the relationship between a target as well as the beam particles. So yes, to the answer to that is that the thinner nuclear targets require less energetic particles, and vice versa. So in other words, the thicker, the more particles need obviously to have energy in order to penetrate that particular target.
Okay, so I can just imagine when you play around with this fancy equipment, what has to date been some of the most challenging targets, and are some of them expensive to produce?
Some targets, yes, they require. They are actually a challenge to produce, and And just to be precise on that, what do we mean is that some cannot be produced under atmospheric conditions due to a process known as oxidation, or in other words, if you were to leave them or if you were to manufacture them in a normal environment, you come the next day, that target is gone, because obviously there's lots of oxygen which reacts to it. So those are the most difficult targets to actually come up with, and what comes to mind as I'm speaking to you is a calcium target and the samarium target.
I see. Okay. And then would I be correct in saying that your job allows the physical science and mathematics, the kids get taught in the school to come to life? Any advice to the matriculants that are getting ready for their final exams?
Yes. I always find this question very interesting. For first, you need to have a questioning mind in order to appreciate the science in life. The basic sciences basically are defined as the scientific disciplines of mathematics, physics, chemistry, and biology. They are called the basics science, or because they basically provide a fundamental understanding of natural phenomena and the process by which natural resources are transformed.
Wow. Okay. So, Dr. Sizwe Buwa, what did you have to study to become a target engineer? What does one have to know to become that? I mean, this seems like a very important job.
Yes. For one to become a target engineer, you need a lot of chemistry background, and obviously some physics background, and on top of this, because of the field that I'm in now, I've also found myself having to learn a lot about vacuum-related techniques as well.
Wow.
So it's quite a number of, skills that one requires in order to obviously perform the kind of job that I'm doing.
And while you're doing the job, you must be learning so much.
Exactly.
And is there anything you would like to share with us that has been a highlight for you in your career and your life?
Yes, I don't think I've done justice to your question, which was asking that how are targets made. Just to go back onto that one.
That's okay.
I can say so much under that question.
I can only imagine.
Yes. The so-called parameters of targets depend on experiment, but there is obviously some requirements which are common. Apart from having the thickness, which is one of the most fundamental parameter, one is to also look at uniform thickness, good mechanical strength, some stability. Obviously, this is now under the beam, as well as the high chemical purity. So in general, we basically classify three methods that we manufacture these targets under. Your first one is your mechanical reshaping, or what is also known as cold rolling in a lab. Your physical methods, that includes your vapor condensation. And lastly is your chemical methods, and there I can cite what is known as electrode deposition. So yes, that is what I thought I should also highlight as one of the
highlights
of the lab.
Oh my gosh, that is so amazing. And Dr. Sizwe Buwa, thank you so much. He is the target engineer from iThemba Labs, and you can check out iThemba Labs at their website at www.tlabs.ac.za to go see what they do. You can also email them at cise@tlabs.ac.za. It's iThemba Labs, and they are doing so much in terms of science in South Africa, advancing knowledge, transforming lives, inspiring a nation. Dr. Sizwe Buwa, thank you so much for joining me, and have a beautiful day.
It's been a pleasure. Thank you very much.
Goodbye.
At the very tip of Africa lies iThemba Laboratory for accelerator-based science, the largest accelerator facility in the Southern Hemisphere and the only cyclotron facility on the African continent. iThemba Labs offers unique research capabilities to local and international researchers. The Cape Town facility also produces radiopharmaceuticals for the diagnosis and treatment of cancer. iThemba Labs is where science comes to life, where real people are using science in various ways to impact the lives of every South African. Visit their Facebook page, iThemba Labs Cape, or email director@tlabs.ac.za.